A banana can turn brown within 20. Here's the thing. Bananas don't even need to be bruised to start browning. Ripening alone does it. Leave one on the counter, and within days it goes from green to yellow to freckled to solid brown. Bite into a bruised spot and it's soft and dark in seconds. Every one of us has thrown out a banana at that point, convinced something had gone wrong inside it. Some of us peel around the spot and eat the rest anyway, quietly convinced we dodged something. But nothing rotted. A chemical switch flipped, and it flips shockingly fast. The assumption is simple. Brown means bacteria, mold, or decay got in. The same conclusion you draw about a moldy slice of bread. It's an easy mistake because we're trained from childhood that any dark, soft spot on food probably isn't safe to eat. That assumption is wrong. There's no rot, no bacteria, and no mold involved in ordinary banana browning. It's a plant enzyme doing exactly what it evolved to do, reacting the instant it's exposed to oxygen. The real cause is hiding inside the fruit's own cells in two ingredients that are never supposed to meet. Banana cells store an enzyme called polyphenol oxidase, and separately, a family of colorless compounds called phenolics. As long as the cell stays intact, a thin membrane keeps them apart, like two chemicals stored in separate vials. Plants evolved this system as a defense. When an insect bites into a leaf or fruit, the same reaction seals the wound with a bitter, sticky barrier that discourages a second bite. But ripening softens the cell walls on its own, and any bruise, bump, or cut tears that membrane outright. The moment the enzyme spills out and touches both the phenolics and the air, the clock starts ticking. Here's the payoff. Mix that enzyme, those phenolics, and oxygen together, and they don't rot, they oxidize. Oxygen steals electrons and builds new brown pigments called melanins, the exact same family of pigment that darkens a cut apple, a bruised avocado, and your own skin in the sun. It is chemically close cousins with rust, iron reacting with oxygen to turn red-brown. A banana peel is basically running its own rust reaction, just with an enzyme instead of metal. Ripening turns this reaction up, not down. A ripe banana pumps out ethylene gas, a hormone that triggers its own cell walls to soften and its stored starch to convert into sugar, which is why a spotted banana tastes sweeter, not worse. This is also why a banana ripens faster sitting next to other fruit. It's not just releasing ethylene, it's absorbing everyone else's too. Softer walls mean more ruptured cells, more enzyme meeting more oxygen, and more brown spots blooming across the peel. The riper the fruit gets, the faster the reaction runs, right up until the whole peel goes solid brown. So brown spots are not a warning sign. They're closer to a ripeness clock, and the flesh underneath is usually sweeter and carries slightly more antioxidants than it did at the store. Refrigeration does slow the enzyme down, which is why cold works, but also damages the peel's membranes, so the skin often blackens even faster while the fruit inside stays perfectly fine. The one real warning sign is smell. A sour, fermented odor means yeast or bacteria have actually taken over, and that's genuinely different from ordinary browning. Judge a banana by texture and smell, not by color. So next time a banana goes speckled brown on your counter, you're not watching it rot. You're watching an enzyme run almost the exact same reaction that turns a nail into rust, sped up by ripening itself. It isn't decay. It's chemistry, running in plain sight on every fruit bowl in the world. If you'll never look at a browning banana the same way again, that's the whole point of this channel. Subscribe, we keep cutting things open.